we're going to talk about vertiports and launch sites to support the safe operation of eVTOLs, drones and other remotely piloted technology categorized under Advanced Air Mobility (AAM). Most will typically be used to transport people. These 3 video segments will highlight these organizations right now that have come forward to identify, plan and discuss how these transportation hubs will integrate with existing infrastructure. The 3 are NASA, which is creating an Advanced Air Mobility Playbook, CASA Civil Aviation Safety Authority in Australia, and Urban Airport Air 1, a pop-up vertiport hub designed and built by Ricky Sandhu in Coventry, UK. We hope you enjoy this production. Please like and subscribe so we can continue to bring you these videos. Are you looking forward to taking an air taxi? NASA is researching where Advanced Air Mobility (AAM) vehicles will take off and land. Several AAM aircraft will have electric vertical takeoff and landing, or eVTOLs, allowing them to take off and land vertically, similar to helicopters on helipads. Several power and operation principles could be used in AAM vehicle types. NASA's Advanced Air Mobility mission is investigating how these vertiports or vertiplexes, many vertiports in close proximity, will integrate with existing infrastructure such as airports and heliports. There is additional research being conducted to look into new landing zones that can be constructed from reused areas, purpose-built sites, or integrated into existing facilities such as a train or bus station. Many of the first instances of eVTOLs taking off and landing will take place at existing airports. In the future, these vehicles will employ their exceptional performance capabilities to land on the tops of skyscrapers or other dense urban locations. Numerous projects supporting the AAM mission are working on various aspects to help it become a reality. There has always been much discussion about seamless mobility. From the airport to your car or a taxi. Or from the train station to your car, and then to your home outside of town. When a new type of mobility is introduced, the first thought that comes to mind is to try to reduce the friction of getting from point A to point B. That is precisely what is happening with eVTOL, or electric vertical takeoff and landing aircraft. Urban Airport is a company that designs, manufactures, and operates aviation infrastructure for eVTOLs, and passenger air taxis ranging from 4 to 8 seats, as well as smaller eVTOLs and drones. Over the last 3 weeks, they've seen 20 different types of drones take off and land from the urban airport. They have yet to see a passenger taxi take off because the manufacturer and operators are all working hard to get them certified. Finally, the urban airport will be a compatible piece of infrastructure that can service these vehicles and allow them to take off and land safely. They can process the passengers, board them, and process the cargo in a safe and secure manner. The integrated patented technology that allows the vehicle to take off from an elevated flight deck distinguishes urban airport. Passengers and cargo can be loaded and unloaded safely and securely on the hangar deck, where eVTOLs can be charged, maintained, repaired, and fixed. Because it is a global business, infrastructure like this could be used all over the world. They believe that the needs for humanitarian aid and disaster relief vary greatly across the globe. Transportation of medical supplies is an example of a more conventional area that crosses from the developing to the developed world. The infrastructure is being built with net zero and resilient architecture in mind, so that it can serve communities by transporting people from point A to point B while also operating in improbable conditions. There are areas in Africa that do not have postal addresses, so items cannot be delivered to them. Even parts of the Middle East have the same technology, so they can geolocate with a partner to within 1 square meter and deliver parcels directly to destinations. Always overcoming problems that arise within systems along the way. This version of the urban airport is extremely lightweight and can be quickly deployed within cargo containers. They can be put up in a matter of days, if not a week. The urban airport here is a real showpiece. It depicts what this infrastructure could look like as well as a variety of different applications and ways this could be used. They demonstrated how it could be used for passengers, as well as how it could be used to improve cyber security and logistics. Consider a number of logistic sorting centers, which are a component of last-mile deliveries. This could be used for deliveries in the city, or it could be used for more remote locations, such as delivering medical supplies. Farmers in outlying areas of cities are interested in moving their cash crops and agricultural produce to cities where they can be sold at higher prices. The goal of management is to have 200 urban airports operational around the world within the next 5 years. The one displayed here is a prototype. There are many improvements we want to make to it. The key component of the urban airport is the patented technology that allows it to be very compact. An ultra-compact, high-capacity aviation infrastructure can be located in high-value areas such as downtown city centers. It could be built within minutes of a mainland rail station. This would result in increased productivity, which would relieve congestion on existing infrastructure and help take some vehicles off the road, thereby helping to clean the air. Advanced air mobility will not replace existing modes of transportation, but will add another layer of mobility to cities as they grow. Certainly, wealthy people will own some flying cars, but there is so much more that this eVTOL technology can do for society. New technologies can appear completely unnecessary until they are suddenly integrated into our lives and establish new status quos, and I believe eVTOLs is firmly in that camp. Industry has been working on creating a new mode of transportation for the past few years that aims to reduce city traffic, while also offering a practical option for more effectively connecting regional areas through a new aviation market. Advanced air mobility is referred to as AAM. They can accomplish tasks that a helicopter or an airplane can never complete using drones, RPAS, advanced air mobility, and all other variations of the spectrum in between. And what's even more exciting is that they can do them more precisely, safely, and creatively. Safety is the main benefit. A helicopter always has a single point of failure that is challenging to repair, whereas a large number of small electric motors can significantly increase safety. As a result, there's a great need for affordable, highly secure transportation. They intend to construct many of them and put them to use in a busy area. There are many things to consider in that situation. The first thing to think about is the flight characteristics of these aircraft, particularly the flight profiles. What does this mean for obstacles in land use planning, as well as trying to figure out how to safeguard vertiports? Where are they going to land and take off with these things? Alternatively, in the case of drones, how do they safely interact with their surroundings? A vertiport is the AAM equivalent of a helicopter's helipad. In the future, they might be installed on top apartment complexes or parking garages all over the city. Larger AAM hubs on top of shopping malls close to freight distribution centers, or next to hospitals may be advantageous in higher traffic areas or regional hubs. The first vertiports will be situated in already built aviation infrastructure. As a result, it will substitute quieter aircraft for noisy ones. The community will then be able to see for themselves why these aircraft are special, and there will be a push for vertiports and more practical places, so perhaps in their retail spaces, shopping malls, and so forth. It all boils down to this evolutionary process of allowing relatively small airports to be dispersed throughout, and maintaining clear pathways between aircraft. In order to produce practical regulations that maintain a high level of safety while enabling industry innovation, CASA has actively worked with the industry. It is crucial that the regulatory framework adapt to market changes as this industry develops. The vehicle being used for this is the RPAS and AAM regulatory roadmap. The means of transportation are those. That is the overall strategy behind CASA's response to the industry's call for the adoption of new technologies. Private engineers were able to join the team and work with CASA to look at what regulations will be required to enable this type of aircraft, and this new type of aviation operation to exist in the future after being invited by CASA to join the technical work group that was formed to help define and sketch out the roadmap. No one has all the answers, but we are working with businesses to determine what the next few years will entail. But what about the following 5 years and so on? Tomorrow won't have any permanent answers at all. It will need to be adjusted as they go. It must change over time. That's advantageous because it enables everyone to meet both the needs of various industries and the community's expectations for these vehicles. It's very encouraging that the international community in this advanced air mobility space understands that our regulatory authorities have policies that support this, and the future is quite promising.